Welcome to Part 5 of Golden Software's demonstration videos for Voxler 2. This demonstration video will cover using Voxler's color map editor, including using the editor to create custom opacity mapping, to create custom color mapping, and to create a custom color map file that can be applied to other Voxler projects. To start this demonstration, I will be using an existing Voxler project file that was created in the previous demonstration video, creating and editing VolRender maps. If you would like a copy of the project file I am using in this video, please go to goldensoftware.com and download it from the Training Videos page under Video 5 using the Color Map Editor. The Color Map Editor dialog contains two sections. The upper section controls the opacity of the colors in the color map. The lower section sets the colors, the value being defined by the colors, and the interpolation method. Let's take a look at the dialog and talk about the various options. Let's access the color dialog to take a look at the color map of the VolRender. In the network window, click on the VolRender module. Now move to the Properties window and click on the ellipses button next to the color map to access the color map editor. When the dialog opens, you'll notice the two sections I mentioned earlier, the opacity mapping section and the color mapping section. In the opacity mapping section, you will see opacity mapping, data value, level ends, opacity, and a histogram displaying the VolRender's data distribution. The small boxes in the graph are called nodes. The nodes show the level of transparency at that location on the color map. The nodes are connected with a line. When using a variable transparency, the line shows the amount of transparency across your data range. You can choose one of the predefined opacity mapping options by clicking on the drop-down menu. Remember that an opacity value of 1 indicates that the color is fully opaque and cannot be seen through, and a value of 0 indicates that the color is fully transparent. If you select Fix Point 2 as the opacity mapping, the entire set of colors will have a 20% opacity and is indicated by the line moving across the graph of your data. Fixed 1.0 is fully opaque colors for the entire color map. Notice the line moving above all of the data? If you select ramp 0 to 0.2, the opacity gradually increases across the data from fully transparent to 20% opaque. If you select ramp 0 to 1, the opacity gradually increases across the data from fully transparent to fully opaque. Again, notice the line across the histogram. The middle ramp has a variable transparency depending on how the data is distributed. The data in the lowest quartile is fully transparent, followed by a linear ramp over the middle half of the data. The data in the highest quartile is fully opaque. You can customize the opacity mapping by dragging the nodes from one location across the data to another. Watch the model as I adjust the nodes. Additional nodes can be added by double-clicking on the line in the graph. Once a node is added, the actual data value can be set by typing in the data value in the data value box. The opacity value for that node can be set by dragging the node or by typing the value into the opacity box. For example, I'm going to adjust the opacity mapping of the model to only display the volume rendering between two isosurfaces, whose values are 2.8 and 3.0. The isosurfaces are already created in the model at these data values. I will set the data value of this node to 2.8 and make sure the opacity is 0. Double-click on the line to add another node, again setting the data value to 2.8, but this time setting the opacity value to 1. Add two more nodes and set the data values in both boxes to 3.0, one at opacity value at 1 and the other at 0. As you can see, I have mapped the opacity for the VolRenderer to display only between these two isosurfaces. If necessary, extra nodes can be removed by clicking on the node to select it, then pressing the Delete key on the keyboard. You can identify which nodes you're working with by the increase in size of the square associated with that particular node. Now let's discuss the color map section of the editor. Again, you should notice that this section is displaying a histogram of the data it's connected to. In this section, there's another drop-down menu that displays predefined color maps that can be applied. Click on the drop-down menu to view the available maps. Select a few different ones and see how the model changes. You can also create your own custom map by adding nodes and selecting the color for those nodes. Just click on the line and add a node. I'm going to add a node to the same area of the data that is mapped to an opacity mapping of 1 in the above section. Once the node has been added, I will select the color. For this example, I'm going to choose green for the vol renderer color. I will also make sure that the data value for this color node is set to 2.9, which is right in the middle of the area we have mapped with the opacity to 1. Once the custom color map has been created, it can be saved and applied to different modules or for future projects by clicking the Save Color Map button. This concludes my demonstration of how to use the color map editor. If you have any questions, please contact Golden Software's technical support.